Good morning everyone. Welcome to One Concept Per Day portal. This is the solution for the concept that I had been put out here on the WhatsApp, and this is on refraction and reflection. Okay, without wasting your time, let us start with this solution. So the questions in this paper had been taken from May 2003, and earlier we had an options paper. So this is from the optics option. But anyway, the syllabus are one and the same, and the problems are also seem to be very good. Okay, now let us start solving this problem. So with the aid of a suitable diagram, define the term refractive index as applied to an optical material. So we need to define the refractive index using an appropriate diagram. Okay, so what you do is you put something like a glass. Okay, you are not going to put a mirror over here because mirror will reflect will not refract. So therefore, this is my incident ray, this is my normal, this is my angle of incidence. Let us say this is my rarer medium and this is my denser medium. I put these on. So as a result of it, this will have a larger refractive index, this will have a lower refractive index. And then I can now say if this is I, then R, the refracted ray, should go like this. Why? Because it bends away from the normal. If that is the case, the angle between the normal and the refracted ray should be your R. Okay. Marks should be awarded for writing down the diagram properly and as well as depicting the arrows for the incident and refracted rays and appropriately putting across the values of I and R. Okay. And then you also have a mark to define the refractive index. So how do you define refractive index? You should write refractive index N is equal to sin I divided by sin R. If you are using this definition, okay, and you write by Snell's law, and if you are using this definition, then you put this one to be N is equal to 1 and N is equal to N. Okay, either you can put like this or you can say refractive index equal to 1 and refractive index equal to N. Okay, so this is also equally acceptable. You can write like this. In fact, see these parameters are very essential. You have to put this parameter, you have to put this parameter, you have to put this one, and finally this one. Okay, this is how you can define your refractive index. Then the diagram shows below the path followed by a ray of red light that is incident on one face of a glass prism at an angle theta to the normal. Okay, so look at this. This is from red light. Let me write red light over here. The red light is now replaced by a blue light. On the diagram, sketch the corresponding path followed by a ray of blue light incident at the same angle theta. This is what is been asked. Okay, so you need to sketch the diagram. So how do you sketch the diagram? We know that whenever we write the spectrum in case of a prism, violet comes here and red comes here. But how do you understand from here? You write like this. What is this? This tells you this is the order of Vidyar that can be written like this. So therefore, violet, indigo, blue, green, yellow, orange, red should come here in this increasing region, right? So therefore, where does blue appear? Blue should appear between violet and red. That means maybe it will appear over here. So what should I do? I should draw two lines over here. So remember, this was 3 mark. Okay. So it says it is incident at the same angle theta because it's white light, and then there is a refraction happening, and thus you will get a ray like this here. And after this, from here, get deviated. Go like this over here. So see to it that the rays are being directed by an arrow, and there is a dispersion happening at the first edge itself, at the first face itself. There is a dispersion happening. Okay, do not just write over here. So therefore, the 3 marks that are being given over here is nothing but first one is given for this one, the second one for the refracted ray or the emergent ray from the second phase, and the final mark is given for, okay, you forgot to write this, final mark is given for the deviation. Now how do you indicate the deviation? Drop a normal here. This would be, let me call this as some alpha 1, and if I drop a normal here, see the normals would be parallel always. Okay, then this angle would be alpha 2. Okay, and you should mention that alpha 2 is larger than alpha 1. This is what you have to mention. So 3 marks for this one. This shows that the deviation for blue ray is larger than that for the red ray. Okay, next. State and explain whether the refractive index for red light in the glass is greater than or equal to or less than the refractive index for blue light. So you need to explain, so what is happening to the refractive indices. Now towards it, Now, how is refractive index defined? Refractive index is defined by n equal to sin I divided by sin r. This is what is being defined over here. So therefore, now if you look at this, when I say this is my alpha 1 and this is alpha 2, what is this alpha 1 and alpha 2? It is nothing but the angle of refraction, right? If this is your angle of incidence, this should be your angle of refraction. Of course, I can say one angle of refraction happens here, the other angle of refraction happens over here. Okay, but anyway, this is an angle of refraction. So if I use this, then what will happen? This should now be equal to sine theta divided by sine r, right? Theta is the same for both the rays. So r, what is value of r? R differs, okay, according to the color. So what I will do is I will just write this as, let me write, so if r is differing, n should also differ. Now let me write for nb is equal to sine theta divided by sine rp, and nr is equal to sine theta divided by sine rr, for red color, blue color. Now what do we know from the previous diagram? We know that this rb, what is rb? Alpha 2. Okay, I'll write it here. rb is equal to alpha 2, r1 is equal to alpha 1. From here, what did we understand? We understood that rb is greater than r1. rb is greater than, okay, sorry, rr. This is what we know. Okay. If rb is greater than rr, if rb is greater than rr, then sin rb would be greater than sin rr. Okay, you can look at it from the diagrams. Okay, after the tables, you will get to know when the angles vary from 0 to 90 degrees. Okay, you cannot have the angle of incidence more than 90 degrees, right? So therefore, so whenever you have something like that, then sin rb will be greater than sin rr, which means that the denominator is increasing. And denominator is increasing, automatically 1 by denominator falls down, and this nb would be less than nr. Okay, so this is all we have seen in the first video. In the next video, we will be able to see some more questions on reflection. Okay, thank you.